guys. This is usually a little bit of a challenge for some students, but we all can do this, so let's give it a try. We're going to graph a system of inequalities. Now, in inequalities, you have to do some shading. I would suggest you use colored pencils. And what we have here is we have one situation where y is greater than negative 2x minus 5. So you graph the line with negative 2x minus 5, and then you're supposed to shade in everything greater than that, which is mean above the line. You also then will graph this line, y equals x plus 3. So you graph that line, and then you shade, it says y is less than or equal to, so we would shade below the line. Now this line here would have to be a dashed line because there's no equal sign. This line here would have to be a solid line because there's an equal sign in the equation or inequality, okay? So let's take a look. This is the line y equals negative 2x minus 5. So it's right here, and it's dashed because it's got a no equal sign. And notice it crosses the y-intercept at negative 5. So it's a y-intercept at negative 5, and notice that the slope is down 2 over 1, and that's how you could create that line. Now, the other line that I gave you to graph is y is equal to x plus 3. So the intercept would be at 3, so plot that point, and the graph is 1, positive 1. So down 1, backward 1, downward, backward 1, and you can create this blue line. Now, deciding where to shade, let's go back to this original one. Y is greater than this line. So if it's greater than, it's going to be above. So that's why this is all shaded up above. All this would be shaded. I'd be coloring all over here. Now, when it comes to my other blue line, it says y is less than that. So as I draw my blue line, I'm going to shade below the line. So this is all getting colored blue. Now, where they overlap looks like a purple color, right? That's actually where all the solutions are to the system of equations, because that's where they both have points in common. So I could use 1, 1, I could use 1, 2, I could use 2, 1, I could use negative 1, negative 1. Any point in this purple shaded region is a solution to these two equations, the system of equations, okay? Here's another situation, okay? We have this equation, 2x plus 3y is less than 6. We could graph our x and y intercepts for this function and create a line that's dashed because it doesn't have an equal sign. We could do slope intercepts for this one, and we could graph it, and we would have a solid line because it has an equal sign. All right, so let's take a look. I graph 2x plus 3y is less than 6, and that is going to be right here because our x and y intercepts are here and here. And it says it's less than it, so you shade below. Now this one has y is greater than or equal to. And so, of course, our y-intercept is at 4, and our slope was negative 2/3, so we drop 2, move over 3 to create this blue line. And we shade everywhere above it because it says y is greater than it. So notice there's no overlap going on. The blue and the red sections don't overlap. So guess what? There's no solution to the system of equations. All right. Here's another situation. Y is less than or equal to 3. Now you know that that's supposed to be a horizontal line. At least I hope you do. Now this one is an absolute value. All right, so we're going to have some fun graphing this. Here's the absolute value. If y is greater than or equal to, or I'm sorry, greater than x plus 4, we know that the vertex is going to be at negative 4. And then we go over 1, up 1, over 1, up 1, and we continue to create both sides of that absolute value. And notice the lines are dashed because there's no equal sign here. And it says y is above it. So above the two lines would be right in here, so I would shade all that blue. Now, as far as y is less than or equal to 3, that's a horizontal line right here, and it says it's less than, so we shade below. So notice they overlap right in this section here. So anywhere in the purple section would be a solution. For example, if I went negative 1, 2, 3, 4, negative 4, up 1, that would be a solution. Negative 4, up 2, that would be a solution. Would negative 4, 0 be a solution? No, because it's on a dashed line. Would negative 4, up 3 be a solution? Yes, because that's a solid line. All right. Here's 2 for you to try out. Let's just do one at a time. Graph these two inequalities and shade, in this situation, below, and this situation, above. Pause your video, give it a try. Welcome back. Let's see how you did. Here is the situation with the graphs, and they would overlap right in here. So you would have solutions over in this section here. So if I said like 6, 4, it would work. All right. Now, you've had a chance to try it on your own. Let's try one more on your own. Graphing these two. Use your x and y intercepts here and x and y intercept here to graph the two lines. This one is solid, this one is solid, and shade. In this situation, it's going to be above. In this situation, it's going to be below. All right, pause your video, give it a try. Welcome back. Let's see what that one looks like. Oh, look at that. You're going to be shading right in between. Okay, so this one was below, this one was above, and there you go. Let's try just one more. Okay, here's your two equations. Graph the two lines. In this situation, you're going to go above, and this one you're going to go below because y is less than. Pause your video, give it a try. Welcome back. Let's see how you did. These two will overlap because this is below, this is above, and they overlap in this section. So all the little points anywhere in here will be a solution. All right, now if you really want to try some advanced work, let's try an absolute value. Woohoo! All right, pause your video, give it a try. All right, here we go. Our nice little absolute value makes a perfect V starting at 5. And this is y is equal to 4 line, and so we shade below because it said less than. And look, right in here are the solutions. Thank you very much for trying everything out, and I will see you tomorrow.